Hello everyone, welcome to the first lecture of AAE 301, Summer 2024 Signal Analysis for Aerospace Engineering. Okay, let me kick off by sharing some details about myself. I'm the instructor of this course. My name is Chan-Yuan, and you can also call me David. I'm currently a PhD candidate in the Autonomy and Control Group in AAE under the guidance of Dr. Denfeng Sun. My research interests include multi-agent systems, resilient control, and cybersecurity. Since this is an online asynchronous course, unfortunately, we will not be able to meet in person. In case you are curious about how I look, this picture of me on the left is taken when I attended the IEEE Conference on Decision and Control in Singapore in 2023. Also, if there's something personal that you would like to discuss with me in private throughout the course, you can reach out to me through my email, kuo70@purdue.edu. Now that I have introduced myself, let's go through some points in the syllabus of this course together. The first thing that I'd like to discuss is the course structure. This course is an intensive 8-week course. In the first 3 weeks, we will cover subjects including complex numbers, inner product spaces of functions, Fourier series, discrete Fourier transform, and sinusoid estimation. These subjects will help you learn how to conduct Fourier analysis on signals. In other words, you'll know how to use fast Fourier transform to estimate sinusoids from experimental data, how to estimate the natural frequencies from beam vibration data, and how to extract the spectrum from the time history. To help you better understand of what Fourier analysis can do, I have prepared an example. Here on the left is a graph that shows the historical data of the number of sunspots in each year from 1700 to 2023. From the graph, we see that the number of sunspot peaks periodically every few years. The question is, how can we estimate the period of the peak? This can be done by discrete Fourier transform, or DFT. When we apply DFT to the historical data, or the time signal, we obtain the power spectrum of the signal. This spectrum reveals the power of sinusoidal components at different frequencies. Since the peak occurs periodically with a strong sign, it's likely associated with a dominant frequency component in the signal. Therefore, we can estimate the period or frequency of the peak by identifying the frequency of the sinusoidal components with the highest power. In the following 4 weeks, we will cover subjects including Laplace transform, inverse Laplace transform, final value theorem, transfer functions, matrix exponential, state space realizations, and mass spring damper systems. These subjects will help you learn how to analyze and design linear time invariant systems such as the mass spring damper systems, which are commonly seen in real life. For example, the landing wheel of an aircraft is a good example of a mass spring damper system. When the wheels touch the ground, a strong impact force will be exerted to the system. To ensure the comfort of the passenger throughout the landing process, we need to ensure the system is stable, which implies the system will dissipate energy introduced during the landing process. In addition, we not only need to prevent large and fast oscillation of the aircraft, but also require oscillation to stop as soon as possible. All these specifications require a good understanding of the mass spring damper system. Now let's shift gear to the textbook and slides for this course. The textbook is a note compiled by Dr. Frazel and the slides are prepared by Dr. Sun. They can both be found on Brightspace. I'll be teaching using the slides, so make sure to have all of them before the lectures. As for the coursework, there will be in total 6 homework and 2 exams, 1 midterm and 1 final. In general, homework will be released on Monday of each week and due on 1 week after it's released. There are 2 important dates that you should keep in mind, July 3rd and July 31st, which are the dates for the midterm and the final. Homework will take up 60% of your final grade and the exam will take up the rest 40%. Please note that late homework submissions are subject to a 10% per day deduction, and homework submitted 3 days after the deadline will not be accepted. In addition, the exam will be taken only online asynchronously. You will be given 2 hours to answer the questions and an extra 30 minutes to scan and upload your work. I'd also like to stress that it is your responsibility to check whether your work is graded without mistakes in time. No changes will be made beyond 3 days after releasing the grade. A piece of good news for you is that I have already uploaded all homework to Brightspace, so you can start early if you want to. On top of that, I've also uploaded 2 sample exams to help you prepare for the midterm and finals. For this course, we will be using Gradescope for homework and exam submission. The release date and due date of each item can also be found on Gradescope. Please make sure to submit your work in time to avoid penalties. Lastly, let's discuss about the office hours. Since only 7 students have enrolled in this class, which implies that this is a relatively small class, therefore we will not have a regular office hours. If you have questions about the course materials or lectures that you'd like to discuss with me, you can either write an email to me and schedule for a discussion via Zoom or create a post on Piazza. In my opinion, I would suggest you creating a post on Piazza. This way, your classmates can learn and benefit from your questions together. Alright, this is the end of the first lecture, and I'll see you in the next one.